Hi there. In this video, we're going to be talking about powers and exponents. All right, so here's an example of a number that has an exponent. Exponents are used to express repeated multiplication. So when I'm multiplying the same number over and over again, then I can use an exponent to do that. A power, consists of a base and an exponent. So this whole thing is considered a power. And when I say things, I would say this is 2 to the power of 4. So you can hear that word power there. In this case, the exponent 4 is telling us how many times I'm going to multiply the base. All right, so let's just label the parts here. So the 4 is considered the exponent. The 2 right here is considered the base. Together, that's considered the power. So I have 2 to the power of 4. And so even though the 4 is little, the power of 4, it's got the power, right? It tells you what to do. So it's bossing the 2 around is what I like to tell people. So how many times is it going to tell 2 what to do? It's going to tell it to do what to do 4 times. All right, so we're going to multiply 1, 2, 3, 4. So the base, has to do what the exponent tells them. So the exponent tells them to multiply 4 times. So 2, 2, and 2. All right, so this is where you use the 4 times. All right, most common mistake is that people like to do 2 times 4 and then think that's equal to 8. That is not the same thing. If I do 2 times 2, I get 4. If I do 4 times 2, I get 8. If I do 8 times 2, I get what? 16, not 2 times 4. 2 times 4 would be 8. Okay, all right, so exponents. Hopefully you remember this. So the first thing we're going to be doing is just expressing expressions using exponents. All right, so I have 1, 2, 3, 4 sevens. Since it's the same thing being multiplied over and over again, I can rewrite this with an exponent. So this would be 7, because that's what's being multiplied, and then how many times, okay? I'm going to tell the boss. I'm going to be the boss of the 7, all right? Tell it to multiply itself 4 times. So 7 to the 4th power. And then I don't have to find the answer to this one because it just says to use exponents. So that's all I'm going to do. All right, here I have x's and y's. So I want to see how many x's I have. I like to go alphabetical, so since x comes before y. I have 2 x's, so I'm going to write this as x to the power of 2 times y. Okay, 1, 2, 3 y's, y to the power of 3. Now, 2 and 3 are special, okay, because we use them so much. They have special names. So we can say x to the power of 2, but we can also call this x squared. And then we can also, with the 3, call this y cubed. So I could say x squared times y cubed. And then also, the dot, is one way to write multiplication. But when I'm multiplying letters, all right, I don't have to even use the dot. If I have a letter next to another letter, it's understood to mean multiplication. All right, this is x to the 2nd power times y to the 3rd power, or x squared times y cubed. All right, in this one, I have a mix of numbers and letters. So I can do negative 2's all together. There are 1, 2, 3 of those, so negative 2 to the 3rd power. Now, on this one, you kind of have to be careful. Since the negative is repeating as well, all right, then I want to include that to the 3rd power. So negative 2 to the power of 3. So I'm going to put in parentheses to show that I want the negative to also be multiplied 3 times. All right, then I'm going to multiply that times 3. Okay, so when I have 2 numbers together, I don't want to write those without a dot or without parentheses, because then that might look like the number 23. So here I'm going to go ahead and use the dot again. And there are 2 3's, so 3 is my base, 2 is my exponent. Okay, and then times, how many a's do I have? I have 1, 2, 3 a's, so times. Now here I don't have to have a dot because I can have a letter and a number next to each other. I just don't want to have 2 numbers together without something to tell me it's multiplication. All right, so just to be consistent, I'm going to use the dot. It's not wrong if you do, you just don't have to. All right, so I had 1, 2, 3 negative 2's. I had 1, 2, 3's, so I had 2 3's, and then I had 1, 2, 3, 3 a's. All right, so that's all I have to do. All right, so 7 to the 4th power squared y cubed, and then this one. All right, 4 to the second, or 4 squared. So it says evaluate. Evaluate means find the answer, just a fancy math word. So 4 to the second power, the 2 is telling me how many times to multiply the base. So this is telling me to multiply 4 2 times. So 4 times 4 equals 16. Right, over here it works the same with fractions, and the negatives inside the parentheses, so that's telling me I want it also included in whatever I'm doing. So negative 2/3 to the third power means to multiply negative 2/3 3 times negative 2/3 times negative 2/3. All right, so if I do, if you're remembering fractions, right, you multiply the tops and you multiply the bottoms, all right? So if I do negative 2 times negative 2, that would be 4, right? A negative times a negative is positive. We use sleeping me in to help us remember. If I have a negative times a negative, my answer is positive. So negative times a negative is a positive 4. But then if I do 4 times negative 2, 4 times negative 2, then that would be 4 times a negative. That now I would do a negative times a positive, so my answer would be negative. So that would be a negative 8. Okay, if I do the bottoms, so I put the negatives with the 2's. As long as you just put it with one of the numbers, you're fine. 3 times 3 is 9, and then if I do 9 times 3, I get 27. Okay, this can't be simplified, so that's my answer. Okay, another way to think of this is just to do 2 at a time. Negative 2/3 times negative 2/3. So negative 2 times negative 2 is a positive 4. 3 times 3 is 9. Then I would do 4/9 times negative 2/3. 4 times negative 2 is negative 8. 9 times 3 is 27. So if it's less confusing to write it that way, you can do it that way too. All right, take a look at negative 2 to the 4th power. This means I'm going to have 4. The negative is in the parentheses with the 2, so I'm including the negative. Negative 2 times negative 2 times negative 2 times negative 2. All right, so when I have a lot of numbers to multiply, this is what I like to do. I like to kind of break it up. So I'm going to do these two. Negative 2 times negative 2, right? A negative times a negative is positive, so this is positive 4. And I'm going to do these two. A negative times a negative is a positive 4. And then I have to multiply these two, all right? So 4 times 4 now is 16. My answer is 16, and it's positive because these are both positives. All right, look at G. How is G different than F? Well, in F, the negative 2 was in the parentheses, so it was included when I started multiplying. When negative is not in parentheses, all right, then it's just the 2 that's applying the 4, right? The exponent only goes with the 4. I'm sorry, the 4 only goes with the 2, not the negative. So this just means my answer is going to be negative. All right, so 2 to the 4th, I'm going to ignore that. In fact, you could write it like this. You could do negative and then 2 to the 4th, kind of like that, just to remind yourself the negative outside. All right, so 2 to the 4th, what does that mean? It means multiply 2 4 times. Right? All right. So the negative's outside. I don't have to worry about it. I'm just doing this part. So 2 times 2 is 4. 2 times 2 is 4, and then 4 times 4 is 16. So this part is 16. Don't forget, there's a negative out front that's included with that. Okay? Make sense? Ask questions in class if you don't understand. All right. 5 to the 2nd power times negative 1 to the 3rd power. All right? So 5 times, or 5 to the power of 2, or 5 squared means 2 5s. So 5 times 5 is what? 25. And then when I do this one, this negative 1 is in parentheses, so that means there are 3 negative 1s. So negative 1 times negative 1 times negative 1. So if I do the first two, negative 1 times negative 1, I get positive 1, and negative times a negative is positive. Now I have to do this one times negative 1. So a negative times a positive, right, is a negative, so this becomes a negative 1. So now I have to do these two, 25 times negative 1, right? And a negative times a positive is negative. So this would be negative 25. Okay? All right. Remember, it says to use parentheses, exponents, multiplication, division, addition, and subtraction when there are multiple operations to evaluate. All right? So what is this? Parentheses, exponents, multiply, divide. Okay, the term we use for this is Pemdas. This is how you remember the order of operations. It always starts with parentheses, then exponents, then multiply, divide together in order, then adding, subtracting together in order. So not add before subtract, whatever comes first. All right, so we're evaluating this time. We're going to have to plug in numbers to our variable. So m is a variable, and it's 3. I'm going to rewrite this problem, replacing the variables with the numbers. This is 3 squared plus, in parentheses, the n is 1. 1 squared minus m is 3, parentheses 3. It's important to write it the same way, right? This 3 doesn't go with the m, it goes on the outside of the parentheses. All right, so since this has parentheses, right, Pemdas, starting with the parentheses. Inside the parentheses, I also have to follow Pemdas. So I start with the exponent. 1 to the second power means 1 times 1, which is 1. So now I have 1 minus 3. I'm not done with the parentheses, so I need to still do it. Can you subtract 3 from 1? No, you cannot. Okay, I can't take $3 from $1. So that means my answer is going to be negative. And we're going to talk more about integers later. So you could rewrite this as an addition problem, make it 1 plus negative 3. Or just think, if I owe you, if I have $1 and I need to spend $3, okay, I'm going to owe somebody $2, right? So I'm going to have a negative 2. 3 squared plus negative 2. And then I'm not done with the parentheses because that negative 2 is in the parentheses. So I want to attach to the exponent just like this whole thing was attached to the exponent. All right? So now this parenthesis is really for the exponent. So I can move on to exponents. 3 squared means 3 times 3. Here, negative 2 to the third power means negative 2 times negative 2 times negative 2. Right? 3 times 3 is 9 plus. Then I have negative 2 times negative 2, and negative times a negative is positive, a positive 4. Positive 4 times a negative 2 is a negative times a positive, so that would be a negative, what, 8. Right, and then 9 plus negative 8. If I have $9 and I spend $8, okay, am I going to have $17? No, I'm not really adding. Okay, so this becomes what? 1. 9 plus negative 8 is 1. All right, last one. Evaluate a plus b squared if a equals 5 and b equals negative 4. Evaluate, find the answer. So a I'm going to replace with 5. B I'm going to replace with negative 4. And I'm going to put, since b is the whole number, negative 4, I'm going to put it in parentheses so that I remember to attach it with the exponent. All right, there are no parentheses that tell us to do anything. These parentheses are attached to the exponent, so I'm going to skip from p to e and do the exponent next. This tells me to multiply negative 4 times negative 4. Negative 4 times negative 4 is 16, right? Negative times a negative, positive. Okay, bring down the plus 5, and then I can move on to addition. 5 plus 16 is 21. Okay, all right, powers and exponents. You got bases, you got exponents. Exponents bossy, tells you how many times to multiply. Remember, you're always multiplying. Okay, don't multiply those, multiply these. What else? Just be careful with your negatives, right? If it's attached, if it's in the parentheses, then it gets multiplied. If it's not in the parentheses, all right, then it's just part of your answer at the end. All right, see you soon.